Okay, so this is a video for question 1, part C. We did a tree just before for part 2, and now we have an open branch on the tree. Now what we want to do is read a counterexample off the open branch. And so the way that we do that is by looking at all of the letters and the negations of letters that are on this open branch. And the way that we get the counterexample is when there's a letter, we assign that letter true. And when there's a negation of the letter, we assign that letter false. And doing this for each letter and the negation of letters will get us a counterexample, but only do it for the open branch, right? So we have here, how many letters do we have in total? We have A, B, C, D, E, F, what others? Up to E, F, G, H. All right. And so we just want to find out what values these letters should be assigned or based on the tree. So right, we have H on this open branch. That means H, we say that H is true. Keep going further back. We have F and D on this open branch. That means we assign F and D true as well. True, true. Keep going further back. We have C, A, and not B. So C, A, and not B on this branch. We have C, that means true. We have A, that's true. And we have not B, which means that we assign B 0. And finally, we have G and E on this branch as well. So we assign them 1. And here we have our counterexample. And what this counterexample says is that assigning these values to these letters will make the premises true and the conclusion false. And we want to test that. That's part. So giving the counterexample is the first part of the question. Testing the counterexample is the other part of the question. And what we do is, the question said to give truth tables. We don't write out full truth tables. We just write out the letters and assign the values to each of these letters using kind of mini truth tables, like the abbreviated truth tables from the week before the break. All right, so have A and not B and C implies D. A and not B and C implies D. So to do a partial truth table for this, we assign A as 1, B as 0, C as 1, D as 1. And then we use the characteristic truth tables for these connectives to evaluate the overall formula. So negation of 0 is 1. The conjunction of 1 and 1 is 1. The conjunction of 1 and 1 again is 1. And then a conditional from 1 to 1 is 1. So this value makes that premise true. Next, we have E. Well, that's easy. Oops. We have E. And, well, based on our counterexample, we just give E1. And so that makes that premise true as well. Next, we have D and E implies F. Based on our counterexample, we assign 1 to each of these. Then for the antecedent of this conditional, we have 1 and 1 is 1. And then conditional from 1 to 1 is 1 as well. And so that makes that premise true. Just separating these. And then our next sentence, to F, G, is it H? Yeah, okay. So assigning letters based on our counterexample, we give 1 to A, 1 to F, 1 to G, 1 to H. Negation of 1 is 0 here. And a disjunction between 1 and 0 is 1. A conditional from 1 to 1 is 1, and a conditional from 1 to 1 is 1. So this counterexample makes this whole thing true as well. And the next premise, G. Well, the counterexample just makes that premise true as well. So far, that's all the premises, and the counterexample has made them all true. And the conclusion, A and C implies B. A and C implies B. Based on the counterexample, we assign A1, C1, and B0. Evaluating the antecedent, we have 1 and 1 is 1, and then a conditional from 1 to 0 is 0. And so the conclusion is false. And so this counterexample that we read off the tree makes all the premises true and the conclusion false. That's what these truth tables tell us. There weren't too many errors on this question. A lot of people just either really got it or really didn't get it. Being able to read counterexamples off trees and knowing why the counterexample does what it does will be important in the second half of the course. So this is the general idea. If you can read a counterexample off a tree, test it with truth tables if you can, or test it somehow using tools we will show you later, to make sure that the counterexample actually is a counterexample to your argument. Well, oh yeah, so one issue that sometimes came up is that people would give a counterexample that wasn't actually a counterexample. Like it would make a premise false or the conclusion true. And that doesn't work because the counterexample is supposed to make all the premises true and the conclusion false. And that's what this truth table-ish method is supposed to show. And so if you have a counterexample and it doesn't work as counterexample, you should go back over your tree and make sure that your tree is right. And that's question 3. Or question 1 part C rather.